Hello everybody, today we're going to do some examples involving mathematical induction. The first example that I thought I'd do is the sum of the first n integers. So there's actually a nice little formula for the sum of the first n integers, and it looks like this. Okay, so here n can be either 0, 1, 2, 3, or any of these whole counting numbers. Okay, so when we do a mathematical induction, we need to check the base case. So for us here, we can actually choose any of these numbers over here to be our base case, but we might just choose 0. So the base case is n equals 0. Okay, so obviously the left-hand side, right? If I sum 0 things up, well, I'm going to get 0. And now the right-hand side, if I put 0 in, I end up with something that looks like this. And again, that's 0. So the base case holds. And now we need to do the induction step. Okay, so when we do the induction step, we need to make a hypothesis, which we call the induction hypothesis. Okay, so what we do is we suppose that this formula holds so we suppose that it holds for all n, and now n is allowed to go from 0, 1, 2, all the way up to some fixed n. Okay? And we consider the sum up to that big N, but then we take the next term as well. Now, by assumption, we have that anything, if we sum it up to this capital N, we have a formula for it. So we can sub that in there. So we end up with this. And don't forget to add this other term here. Now we're in a position where we can factorize. So I might yank out this n plus 1, and then the leftover stuff is n over 2 plus 1. Putting this over a common denominator gives us n plus 2 all over 2. And now we can do a little bit of rearranging here. And we've recovered our original formula where n plus 1 is in replace of the n from over here. And so this means that we've completed the induction. And so we can do a little proof box here. And so this formula does indeed hold for all natural numbers greater than or equal to 0.